So you might remember I have a Proxmox Backup Server. I use this for backing up all of my Proxmox systems and also a lot of my data store datasets in my cockpit container. But one thing that's always irritated me about the system is how much power it uses. It's also kind of loud too. Now being loud alone isn't a bad thing. It's down in the basement. I don't have to hear it unless I'm filming. But the power consumption does really add up. If you build your Homelab out of used enterprise servers, like this HP Microserver I'm using, they're not very power efficient. So, since my backup system only really needs to do backups once a day, I figured it'd be good to shut it down or hibernate it when I'm not using it. So that's what I set out to do in this video. So come along on this adventure. So here's a look at my home energy monitor. These labels directly match what it says in the breaker panel, so that's why it's called shop lights, even though it actually powers all my network equipment. So you can see here we can consume up to about 230 watts. This is where the power went out, so we lost data, but it was about 215 here. And then when the lights actually come on, it jumps up over 300 usually. Now this power is the total of pretty much everything in my Homelab. So it's the backup server, but it's also the main server, my TerraMaster NAS, my 2 network switches, including the PoE switch and everything powered by the PoE switch, my Protectly OpenSense firewall. I have a UPS that powers all those things except the backup server, and a cable modem, a couple things like that. So this is the sum total of everything running my house and the backup server, not just the backup server. So to figure out how much power is the backup server, I shut the backup server down last night. And so this is yesterday with 220 watts. This is the lights actually coming on because there are lights on the circuit. And then I played with it for a while, and then eventually I turned the server off. So it was down to about 164, and then it dropped to about 155. So that's a savings of from 220 down to like 160. So 220 minus 160, so 60 watts, and that's pretty much running continuously. Now this is with the backup server off, but still plugged in. It still draws about 6 watts in that condition to power the IPMI, and I think that's worth it. So, but this 60 watts has been going on for 10 months now. So how much has this cost me? So it's 60 watts, there are 24 hours in a day, there are 365.25 days in a year, and about 1,000 to get to kilowatt hours, 525.96 kilowatt hours. So I pay between 16 cents and 23 cents, depending on if it's off-peak or on-peak. So we'll say 18 cents, so that's about 100 bucks. So not too bad, but we can do some savings. And the scripts for this are really not that hard to do. Now this should work for Proxmox VE. It'll definitely work for other Linux systems. The difference is just how you determine when the system is ready to turn off. So let's jump into the solutions I tried and what I ended up with. So first I went to the glorious Arch Wiki, which has pretty much everything you need to know about modern Linux. Arch is very up to date. They're on the bleeding edge of Linux, and so they have really good documentation of this. And so here are all the different sleep modes that Linux supports. So we could do suspend idle, but I'm going to guess that the microserver doesn't support that. We could do S3 sleep, suspend to RAM. So in this case, the system turns off everything but the RAM. This should be low power because my drives are off, but we'll see. Next we have S4 sleep, which is hibernate, and hybrid sleep, which does both, and if the RAM manages to deplete itself, it'll restore from the hybrid file, otherwise it'll restore from RAM. So these two are my targets here initially. So ArchWiki is very optimistic. It says system control suspend should work out of the box. So I tried system control suspend and the whole system locked up. It turns out the HP Microserver doesn't support S3 sleep, and it just locked up. Great. So how about hibernation? Let's try that one instead. So for hibernate to work, we might need to follow the instructions at hibernation. Okay. So we need a swap file, and we need to configure innerMFS, and we need some other stuff. So even if your partition is smaller than RAM, you have a good chance. That's not guaranteed. So in my system, I have the unfortunate case where I have much, much less swap space than I have RAM. I have 1 gig available that I can swap into. That's on a microSD card. That's a pretty terrible place to write a hyper file every night before I wear out the SD card. That's my boot drive. I could write to the ZFS pool, but I can't load a Hibernate file off of ZFS because it has to load directly off the index on a disk. So it basically needs its own dedicated Hibernate partition for that to work. So I actually did try to do it on my 1 gig swap partition that I don't use on the SD card, and that one crashed too. So no Hibernate for me. So that leaves me with completely powering the system off and powering it back on. And one of the reasons I didn't want to do that is because systemd has the ability to automatically wake the system for timers. So when the system goes into suspend or hibernate, some parts of the system are still on, like the real-time clock, and systemd can calculate some time in the future that it wants to wake up and wake the system back up. And so it's pretty easy to just write a systemd timer, and in that configuration of the timer say, wake the system if you need to. And then that'll wake the system and get us back going. So I wanted the whole thing to be self-contained, but if I shut the system down, I have to rely on wake on LAN. So another system on the network will send a wake on LAN packet, wake the system back up. So that's what I ended up settling on. I have another server sending wake on LAN packets, and then the backup server shuts itself back down later. So now would probably be a good time to talk about my plans for when I'm going to shut down, when I'm going to wake up, and how I'm going to do backup still. So here, down below, I'll see if I can make a graph of time, or maybe on the side or something. Basically, at some point, I need to wake up the backup server. After that, I need to give the backup server time to boot up because it's really, really slow to boot up. The post tests on this system are just outrageously long. Then after that, my Proxmox systems can do their backups. These are scheduled to start at a certain time, and they assume the backup server is already running at that time. 4 different servers that feed into this. So there's the TerraMaster NAS, that's my NAS that I use every day. There's a LXC container on the TerraMaster NAS that's backing up my video data. That's separate. Then I have the MegaLab, that's the box PC. And then my web server out in Virginia, that one's also backing up to PBS as well. So all 4 of those have some time of day at which they do backups. In addition to that, PBS also has prune jobs and verified jobs, which run periodically. So we need to set those timers also to be in my time window as well. The final thing to think about is some of these jobs can be very, very long. So doing a full video backup can take like 13 or 14 hours, partly because PBS is not the most efficient at file backups, and they have some patches to fix that. But I need to be aware that the backups could potentially take a very long time, but it depends on what day it is and what we're backing up that day. So anyway, the timeline I settled on. Here we have on-peak and off-peak electricity. On-peak starts at 11 a.m. and ends at 7 p.m. on weekdays. I didn't want to write my schedule to deal with weekdays and weekends, so we assume that we get off-peak energy at 7 p.m. every day. So 7:05 p.m. we send the wake on LAN packet. So that's our first thing. The system takes about 2 minutes to boot up, maybe longer. So then 7:07 or so, system's booted and ready to go. So then at 7:30, I have the backup start. So big store. So I have them staggered by a few minutes each, just, I don't know, it seemed like a good idea. So Terra has its schedule, Iridium has its schedule, MegaLab has a schedule, and the web server has a schedule. And those are all staggered within a 30-minute time from 7:30 to 8 p.m. Most of the VM backups take just a minute or two, same with the container backups, but the video backup could take up to 13 hours, so that one could be running for a very long time. Then after this, I have the prune and verified jobs scheduled. So those all start at 8 or a little bit after 8. Those don't run every day. So then at 11 p.m., the system will start checking to see if it's safe to shut down. And it does this by calling Proxmox Backup Manager and asking how many tasks are in progress. So every backup job, prune job, verify job has an associated task in the Proxmox backup system. And if we just ask how many tasks are there, and the answer is not 0, then we can't shut down yet. It's not safe. So essentially what the script does is starting at 11 p.m., it gets started by a systemd timer. That's when we're going to start allowing shutdown. And every 5 seconds it asks that question, are there tasks running? And if the answer is no for 45 seconds straight, then it says shut down. The end. So let's see how I actually did that with some scripts. So first we need the systemd scripts that run to wake the system up. So I found the MAC addresses of my 3 Ethernet interfaces, so I'm using EN01 primarily, so I'm going to use that MAC address. Over on Iridium here, I just said I install wake on LAN, and it says already installed, so now I can wake on LAN and just type the MAC address and it'll wake it. So then I can say which wake on LAN, and this gives me the full path. It's in user bin just like I expected. So then I wrote this nice service unit, and if we take a look at what that looks like, So that's in SE systemd system. That's where we put our own custom systemd units. It's called wakebigstore.service, and it's called wake up big store, so it just calls wake on LAN with that, and that's it. It's a one shot, so it just does it and it's done. Next up, we need a timer to call this service. So I wrote a timer here. So 7 p.m. local time, 1905. And that's called the same thing, except it's a .timer instead of a .service. So same as before. Yep. So then with system control, we do daemon reload because we edited files. So then we don't want to enable the service because it doesn't happen automatically. We want to enable and start the timer, so the timer happens automatically. So and then we can list timers and see what happens. So you can see I've got a bunch of things here. So these are my backup scripts. I got the Wakes Big Store, YouTube download, all that good stuff. So this particular one is going to happen again in 20 hours. So that's the wake up side. But how about the shutdown side? Let's go look at that one. So if I want to manually wake it, I can just come into Iridium here and say start. And that'll just kick it off once, which will wake up the server. So backup server booted up. Let's take a look at how it's going. So in my blog post, I have all the scripts posted. Here's the script I'm using. So I'm calling Proxmox Backup Manager Task List. So let's see what happens if we just run that. So it gives us this nice, beautiful thing of what's going on. And if there's no tasks, it just returns empty. So in this case, we need 3 files. So we need a bash script. So basically it has a count. It counts up to 10. And every time it waits 5 seconds. So first it checks if the task list is empty. If it's not empty, then we continue to wait. If we're empty, then we count up. We make this nice thing of how many seconds there are left. And then if we get to the max, then we shut down by just calling shutdown now. That's it. So then we have a service that calls it. So I put it in user local bin and called it Auto-Shutdown. And we have a timer. That's pretty much it. So I open an SSH session here, so there's no tasks left. So if I kick off that timer, and then I immediately look at the status, so you can see here it says time until reset is 45 seconds, 40 seconds. Ask it again, it'll say 35 seconds, but then as soon as I come over here and I start a shell, that'll start a task. So now it's going to be stuck at 30 and it's not going to shut down, but it's going to reset back to 50 seconds. So if I close my shell again, the number of tasks goes back to 0. There we go, we're at 45 seconds again. So if I wait 50 seconds, this thing will just shut down automatically. And there we go, it shut down. So also in the blog post, I have some other minor things I've done. So I mounted the root file system as no A time just to reduce wear. I moved the Proxmox backup logs onto my ZFS pool instead of the boot pool because my boot pool is a microSD card. If your boot pool is not a microSD card, this probably won't matter to you. And because the system is entirely dedicated to ZFS, I've increased the ARC limit to a very high number. So the system RAM will always show up as being very much used, but that's ZFS doing its thing. So yeah, it's all a blog post. So, hope you guys enjoy this little tidbit on Proxmox Backup Server. I always like working with systemd. Systemd services and timer units are just so handy in Linux. You could, of course, use this method for pretty much any other Linux-based system that uses systemd if you want to. You just have to have a way to query when it's safe to shut down. In this case, I'm just querying Proxmox Backup Manager. But if you have some other way of knowing when it's safe to shut down, you could do it the same way. This video doesn't have a sponsor, so if you want to donate or tip me anything, link down in the description to my Ko-fi. I always appreciate that. If you want to chat about it on Discord, link down below for that as well. And I'll see you guys on the next adventure.